All right, welcome to This Explainer. Today, we're diving into something truly fascinating, a real-life collision between hard science and the legal system. We're going to look at how complex network theory, statistical physics, and computer science were literally used as a legal defense strategy. I mean, it's not every day you see complex mathematical formulas brought into a courtroom to completely deconstruct a criminal charge, right? But that is exactly what happened in the case of Dr. Chen Jingyan. We're going to unpack the science behind his defense and objectively look at how hard data was used to challenge a highly subjective legal standard. And, this isn't just some obscure courtroom drama. The outcome of this case fundamentally forces us to question how our traditional laws are supposed to govern our incredibly complex, messy digital lives. So think about your own social media for a second. Let's say you have a modest following. Can your one retweet literally disrupt society? This incredibly fascinating question sits right at the center of Dr. Chen's case, and it sparks a profound clash between pre-modern justice and modern science. It almost sounds like a riddle, but in the eyes of the law, the answer was presumed to be an absolute yes. Dr. Chen, however, used his deep understanding of physics and complex systems to argue that, scientifically speaking, this assumption isn't just unlikely, it's actually mathematically impossible. Let's look at exactly how he proved it. So, here's our roadmap for today's explainer. First, a retweet causes chaos. Second, the science of networks. Third, scale-free networks explained. Fourth, the edge node defense. And finally, law versus complex systems. Let's jump in. Part 1, a retweet causes chaos, the micro-action versus the macro-accusation. Dr. Chen was hit with a serious legal accusation. The claim was that his tiny action, literally a single retweet from an account with fewer than 100 followers, caused massive, macro-level public disorder. The judicial system here was operating on a very traditional, mechanical model of the world. Think of it like old-school Newtonian physics, right? You perform a measurable action, and a direct proportional reaction happens. Because of that mindset, the law assumed that forwarding a specific piece of information directly and linearly resulted in severe public disorder. But wait a minute. This whole framework assumes that a massive social media platform is like a perfectly still pond, and a retweet is a giant boulder thrown into it, causing ripples that hit every single shore. Is that actually how the flow of digital information works? That brings us to part 2, the science of networks and the actual nature of the system. To understand this, we have to look at Eric Brewer's foundational CAP theorem. It's a massive concept in computer science, and it proves that absolute order, or consistency, is literally mathematically impossible in a highly available distributed system, like, say, a global social network. The theorem basically states that out of 3 ideal traits, consistency, availability, and partition tolerance, a system can only ever achieve 2 at any given time. Because social networks span the globe and absolutely have to tolerate delays or network partitions across countless servers, they are forced to sacrifice absolute consistency just to remain available. Think about trying to perfectly sync the feeds of hundreds of millions of users simultaneously across the entire planet. It physically cannot be done without breaking the whole system. So, what's the crucial takeaway here? It's that chaos and inconsistency are built-in physical features of these networks. They are not bugs, and they are definitely not anomalies created by one random user's retweet. It's just the structural baseline. When you experience lag on an app, or when you notice tweets showing up completely out of order on your timeline, you are witnessing real-time symptoms of this exact baseline. Social networks are naturally noisy, inconsistent, and frankly, deeply messy. That's just the necessary price they pay to be fast and globally accessible. Dr. Chen argued that the legal system was looking at this built-in background noise of the internet and completely incorrectly labeling it as a crime caused by his specific isolated action. You just can't blame a single user for the inherent messiness of a complex system. Moving on to part 3, scale-free networks explained. Let's talk about the network topography. Social networks really aren't democratic. They're actually highly unequal structures dominated by a specific distribution of power known as a scale-free network. This topography is defined by the Barabasi-Albert model, which dictates that node connections don't follow a normal bell curve. Instead, they follow what's called a power law distribution. This is driven by something network scientists call preferential attachment. In plain English, it's the rich get richer phenomenon. A new user joining a network is way more likely to follow an already famous account than some unknown one. Over time, this creates extreme structural inequality. A microscopic fraction of users amasses an astronomically high number of connections, while the vast majority of us have almost 0. To visualize this, think of the hub nodes as your major media outlets, international celebrities or massive influencers. They make up a tiny percentage of total users, but they hold almost all the influence. They are literally the skeleton of the network. Then you have the edge nodes. That's everyday users like Dr. Chen and probably you and me. Remember, Dr. Chen's account had fewer than 100 followers. We're basically the millions of tiny dots scattered on the absolute outer edges. In a scale-free network, information cascades and true viral reach are entirely dependent on those massive hub nodes picking up the signal. Without the hubs, the edge nodes are pretty much just shouting into the void. Which leads perfectly into part 4, the edge node defense. Let's look at the mathematical defense strategy. Because of their very unique structure, scale-free networks have this extreme robustness against random disruptions from edge nodes. Network robustness is basically the ability of the system to maintain its connectivity and core function even when parts of it are removed or broken. If you were to randomly select and delete nodes from a global social network, statistically, you are guaranteed to almost always hit an edge node, simply because there are hundreds of millions of them compared to just a handful of hubs. And since these edge nodes only connect to maybe 1 or 2 hubs and rarely to each other, removing them or reacting to their specific activity doesn't change the shape, flow, or stability of the overall web whatsoever. Physicists Reuven Cohen and Shlomo Havlin essentially proved a network's invincibility against random attacks using the Cohen critical threshold formula. They demonstrated mathematically that in a scale-free network, the critical point of collapse basically approaches 1. This is a mind-blowing fact. It means you would literally have to remove nearly 100% of the nodes in the entire network before the system's global connectivity actually broke down. So random edge nodes have a mathematically negligible impact on the overall system. And because Dr. Chen's account had fewer than 100 followers, his mathematical influence and capacity to cause systemic disorder was practically 0. His account's activity was mathematically incapable of creating a macro-level cascade on its own. For a legal charge to claim that his single micro-action directly caused severe public disorder, well, that means the legal charge is claiming an event occurred that outright defies the established mathematical laws of statistical physics. The math just does not allow for that outcome. An edge node in a massive network is literally like a single grain of sand in the ocean. Even if his specific edge node was entirely deleted, the whole network structure would remain completely unchanged. The impact of a retweet from an account that small is so infinitesimally tiny that it gets immediately absorbed by the system's natural damping mechanisms. Now, we've all heard of the butterfly effect, right? The idea that a butterfly flapping its wings in Brazil can cause a tornado in Texas, but that only happens in highly sensitive, purely linear models. Scale-free networks are explicitly built to be immune to butterfly effects. They just swallow up random noise without destabilizing. Finally, part 5, law versus complex systems. Let's look at the epistemological clash here. The epistemological disconnect between these two worlds is profound. The law assumes linear causality and uses subjective language, while science relies on nonlinear quantifiable metrics. The legal framework in this case was basically using outdated Newtonian mechanics to judge a quantum-level social reality. It's kind of like using a wooden ruler to measure the speed of light. The law looks at the event and says, action A caused outcome B, pasting on subjective, vague labels like severe disorder. But science looks at the exact same event and says, hold on, this is a complex, nonlinear system where outcomes are determined by structural topography, power laws, and highly measurable metrics. The legal conclusion that one tiny node guaranteed severe macro-level chaos is quite literally an impossible event in the realm of statistical physics. For an edge node to cause a systemic collapse, the entire social network would already have to be in a highly unstable, hypercritical state. Think of it like a massive room completely filled with highly combustible gas, just waiting for a single tiny spark. If a spark goes off and the room explodes, the institutional responsibility lies with whatever structural forces filled the room with gas in the first place, not the microscopic spark itself. In Dr. Chen's case, the prosecution provided absolutely no data to prove the network was inherently in such a volatile, critical state. Dr. Chen summarized this whole clash perfectly with a really visceral analogy about the massive scale of cause and effect. He stated, "My retweet is like breathing out carbon dioxide. You cannot sentence me to life in prison because the earth is warming." I mean, wow. Yes, breathing out carbon dioxide technically adds to the atmosphere, just like a single retweet technically adds to the global data flow. But to legally attribute macro-level climate change to one single person's breath or macro-level societal disorder to one edge node's retweet is a complete breakdown of logical, scientific causality. So as you scroll your feed later today, I want you to ask yourself, How must our institutions adapt their linear understanding of causality to govern a complex, nonlinear world? How do our laws need to evolve to protect everyday users, like you and me, from being held liable for the sheer, mathematically proven physics of the modern internet? It is absolutely vital that the rules governing our digital spaces rely on objective, quantifiable realities rather than subjective, pre-modern assumptions. Thank you so much for joining me for this explainer, and keep questioning the mechanics of the world around you.